In this example, we are told that in 3D modeling, creating a circular hole or object in a mesh can be done using multiple methods, one of which is called box modeling. To box model a hole, the modeler will create a hole using a polygon, such as a square, hexagon, or octagon, and gradually increase the subdivisions to create a polygon with more and more sides, until it looks closer to a circle. Imagine taking a polygon, say a hexagon, and then increase it to an octagon, then increase it to something with 10 sides, and then 20 sides, and then 30 sides. Each side length is going to get smaller and smaller and smaller, and to the naked eye, it may appear more like a circle than like a polygon. Let us say here that the octagon in the image to the right is modeling a circle with a radius of 5 units. What we're going to do here is find the perimeter of the octagon, and then find the circumference of the circle that it is modeling. We'll round both answers to the nearest hundredth of a unit. Then we'll also see how far off the perimeter of the octagon is from the circumference. Well, here, if we have an octagon that is trying to model a circle, well, that would look something like this. I'll put the sides in black. So we have something that looks kind of like a wheel here, where I have that octagon on the inside that's trying to model the circumference of a circle. And if you notice, those lines are pretty close. They're obviously more rounded for the circle, so that means our octagon is going to be a little bit short of the perimeter. But our goal here is to first find the perimeter of that octagon. Notice that in that octagon, it takes the image and it divides it into 8 equal pieces. It is taking one full rotation and dividing that into 8 equal pieces. Meaning that one of these pieces would have an angle measure on the inside that is 1/8 of a full rotation, or 2 pi. So that means our angle measure on the inside there is pi over 4. This is trying to model a circle with a circumference of 5, which means that the distance from the center of this image to the edge of the circle would be 5 units. And that would also represent the distance from the center of the circle to the edge in these triangles. Meaning that we have these two side lengths that are both a value of 5. Using just this information, we could use the law of cosines in order to solve for the missing side length here. I will make a quick note though that it is possible to solve for the other remaining angle measures at this point for each of these triangles, and then use law of sines instead. But here I'll demonstrate using law of cosines because there's not much more information we need at this point. If I do want to solve for x using law of cosines, that will look like x squared is equal to the other two side lengths squared and added, minus 2 times those two side lengths multiplied, as well as multiplied by the angle measure across from my side length of x, which is pi over 4. X then would be the square root of all of that. 5 squared and 5 squared is 25. Add those together, you get 50. And then this term, this is 5 times 5, which is 25, times 2 is also 50. And cosine of pi over 4 is square root of 2 over 2, but for the sake of it, I'll keep it as cosine of pi over 4 this time. Let's approximate that. We'll find the outside edge of one of these triangles. We'll use a calculator for that purpose. Note that if I keep this as cosine of pi over 4, I do need to make sure I am in radian mode for that. Before I do square root of 50 minus 50 cosine of pi over 4. Although we should already know cosine of pi over 4. This gives us approximately square root of 3.8268. That is the length of one of these outside triangles, or the outside edge of one of these triangles, for the octagon. The perimeter then would be all of these outside edges for each triangle in this octagon, of which there are 8. So we have this triangular image repeated 8 times, which means that we simply need to take this outside edge and multiply it by 8 in order to get the perimeter. So I will multiply that previous value by 8. That gives me 30.6147. So that gives me one of my answers, or to the nearest hundredth of a unit for this, that would be 6.1. But that's not my final answer. That's only a portion of it, because we were also asked how far is this from the circumference of the circle. Well, the circumference of the circle you can calculate circumference using 2 pi r, where here the r is 5. So that is 10 pi, or 31.41, or 31.42 if you approximate. You can use a calculator if you need to for that. That's the circumference, and the perimeter is pretty close to that, but it is still off a bit. The difference is simply 31.42 minus 30.61, which gives me 0. This would be 81. That is how far off the perimeter of this octagon is from the circumference of the circle that it is trying to model.